Now, if you recall, we're talking about the moving average processes, where we started with the first order moving average, second order moving average. Then today, we are going to talk about the qth order or moving average of order Q. That is the last process in a moving average that we're going to talk about. Then when we are done, we're going to talk about the partial autocorrelation functions. Isn't that now you know what is an autocorrelation function and how do you draw the autocorrelation plot? So later on, we're going to do a partial autocorrelation function. And then from there, we are going to start with a new processes called autoregressive process. So without any waste of time, let me just go to the board. Go to the window journal. Okay. Okay, let me share. There we are. Now, this is lecture number 8. So, and we're going to talk about the moving average process of order Q. And then, as you know, moving average processes are always stationary. So if they are stationary, so we are allowed to calculate the autocovariances and the autocorrelation functions. So this is lecture number 8. Lecture number 8. It's about the qth order moving average or moving average of order Q. Okay. Process. So the question is, what is the qth order moving average? Qth order moving average is defined by ZT equal to, not ZT, sorry, XT as a process. Not ZT, rather XT equal to ZT plus theta 1 ZT minus 1 plus theta 2 ZT minus 2 plus theta 3 ZT minus 3 plus theta Q ZT minus Q. Okay, that is the moving average of order Q process, where ZT is a white noise. Okay, and theta I, where I is ranging from 1 to up to Q, are real valued constant. Okay.
Hello.
Evan, seu salon.
Students who chose courses just because they want to.
Hey guys, can you hear me? Everyone?
Yes, sir, we can hear you.
Sorry, I was disconnected and I don't know whether you. Can I start from the beginning or
Yeah, yeah,
where can I
yeah,
start?
yeah.
Start from the beginning. Okay.
From the beginning.
Okay, it's fine. Fine. Can you be able to see my page there?
No, not yet.
No,
Say,
sir.
Not yet.
don't
No.
forget to
We can't
record
see
class.
anything.
Okay,
It's
it's fine.
recording.
Yeah,
Okay.
it's recording.
Nah, it's not working. These online classes.
Okay, wait. I'm still connecting. Can you see my window now? Hello?
Yes.
You can.
Okay, it's
Yes,
fine.
yes.
Yeah.
Did you manage to write this?
No.
Okay.
No.
Okay,
No.
No.
okay, it's fine. Let me start from the beginning. I was saying that today we're going to talk about the moving average of order Q. As you know that all moving average processes are stationary. So even moving average of order Q is stationary. So the moving average of order Q is defined by the process xt, which is equal to zt plus theta 1 zt minus 1 plus theta 2 zt minus 2 up to theta q zt minus q, where zt as usual is a white noise and theta I are a real valued constant. So now, because moving average processes is stationary, so we are allowed to calculate the autocovariance functions. So that is why I started by calculating the expected value of xt, as you see there, which is equal to the expected value of zt plus theta 1 zt minus 1 and so on. And at the end of the day, because of this condition that says zt is a white noise with mean 0, so that means expected value of xt is going to be equal to 0. Okay. So now for the next page, I was about to calculate the gamma
Several
zero. Eh? Come again?
Oh, I was still writing
Writing.
down what.
Okay, it's
Yeah.
fine. Let me just
We
go
was-
back.
Yeah.
So that's it. So after calculating the expected value of xt, we have to go to gamma zero, or sometimes we call it the var of xt, which is the autocovariance functions at leg 0, which is defined by the curve of xt. So okay, are you still writing? Just want to go to the next page. Still writing?
No.
Okay, we're
Yeah,
done.
So you can
we're
go to the
done.
next
Yeah,
page.
I understand.
Okay, thank you. So like I said, we just want to calculate gamma zero, which is equal to the var of xt. If you just want to use var of xt, you can use that one. But this time around, I'm going to use the curve of xt. It's called the var of xt. which is equal to the curve. What is xt? Xt is equal to zt plus theta 1, zt minus 1, plus theta 2, zt minus 2, plus theta 3, zt minus 3, until theta q, zt minus q. Okay, that's xt. So another xt will be zt again, plus theta 1, minus 1, theta 2, zt minus 2, theta 3, zt minus 3, up to theta q, zt minus q. Then we close the brackets. That is the curve of xt, xt. Okay. So therefore, from there, you have zt and zt, the curve of these, because they are not independent, they're going to give you sigma squared z. And the curve of zt and zt minus 1 is going to give you sigma squared z. Curve of zt minus 2, zt minus 2, sigma squared z. The curve of zt minus 3, zt minus 3, sigma squared z. The same applies to the curve of zt minus q, zt minus q. It's going to give you sigma squared z. So all in all, you're going to get the first one, the curve of zt and zt. So I'm skipping another information there. So I'm just jumping to this one, sigma squared z. Okay. So sigma squared z is the curve of zt and zt. So I jumped that step. Okay. Plus theta 1 times theta 1 is theta 1 squared. The curve of what? Zt minus, the curve of zt minus 1, zt minus 1. And the curve of zt minus 1, zt minus 1 is sigma squared z. So here you are going to have what? Theta 1 squared, sigma squared z. Okay. Same applies to this one. Theta 2 squared, sigma squared z. And this one, theta 3 squared, sigma squared z. And the last one, theta q squared, sigma squared z. Are we together? That's step number 2.
No, we are not together, sir.
You are lost.
Yeah, step number 3 after curve of 30
Yeah.
plus.
So you don't know where is it coming from.
Yes.
I said I skipped another step there. I thought maybe you are with me. Okay, let me just erase this and include the step that I've skipped. I thought maybe you understand where is it coming from, but anyway, let me just go back. Here, from here, that is why I wrote this line, black lines there. We're combining ZT and ZT. So the first one, you're going to have curve of ZT and ZT. Okay? Plus theta 1 squared, the curve of ZT minus 1, ZT minus 1. The next group, plus theta 2, the curve of ZT minus 2, ZT minus 2. The next one, plus theta 3 squared, the curve of zt minus 3, zt minus 3. Okay. Then the last one.
Sir, it's theta 2 squared, sir.
Yeah.
It's
Oh,
theta 2
yes.
squared.
Thank you. The curve of zt minus q, zt minus q. Are we together? So this is the step that I've skipped. I thought maybe you understand. Then the fourth one. So the curve of zt is like the variance of zt, and the variance of zt is sigma squared z. So that is why here now we're having sigma squared z. That's the first one. Second one is theta 1 squared. Curve of zt minus 1 is like the variance of zt minus 1, and the variance of zt minus 1 is sigma squared z. So we are going to have sigma squared z. The same applies to this one, to the 2 squared, sigma squared z. Theta 3 squared, sigma squared z. Until to the last one, theta q squared, sigma squared z. Are we together? I think it's clear now.
Yes, sir,
Then
it's clear.
the next step will be for us to find the common factor. As you see, sigma squared z is appearing everywhere. So now we just take it out as a common factor. So you're going to have what? 1 plus theta 1 squared plus theta 2 squared plus theta 3 squared plus theta q squared. Then you close the brackets. You see? So now our gamma 0, which is equal to the curve of xt, is equal to 1 plus theta 1 squared plus theta 2 squared plus theta 3 squared up to theta q squared, sigma squared z. But this last step here, you can write it in the form of summation, because as you see, we are summing everything there. You can write it in the form of summation. So when you want to write it in the form of summation, I hope you're done. Okay,
Yes.
can I go to
Yeah,
okay
we're done.
now? Okay, so now gamma 0, if you want to write it in the form of summation, so gamma 0 will be equivalent to the summation of I equal to 0 theta I squared, I starting from 0 up to q, theta I squared, sigma squared z. Is that true? Is it giving us the last step there? Any comment?
Sir,
Yeah.
so what about the one at the
Yes,
beginning?
I wanted you to comment about that one. So, because this one doesn't give us the last step there, so we have to include something here. And then, so provided our theta 0 is equal to 1. So therefore, this now can be equal to the last step there. Are we together?
No, sir. Can you please repeat what you just said?
Oh, yeah, sir. Okay.
You don't get it. If you check the last step here, if you substitute from there, your I by 0, you're going to get theta 0 here. You get theta 0 here instead of 1. But the rest are going to be the same. So to get 1 there, so that is why we added this condition, theta 0 is theta 0 here equal to 1. You get it? If I equal to 0, you're going to get theta 0 squared. But remember, theta 0 is 1. So it's 1 squared. And 1 squared is the same as 1. So that is why you're going to get 1. If I is equal to 2, is equal to 1. So you're going to get theta 1 squared, which is the same as that one. Theta I equal to 2. Theta 2 squared. I equal to 3. Theta 3 squared, and so on. So you're going to get the same thing as what we got on the last step there. Okay. So that is your gamma 0. Then from there, you continue to gamma 1. Calculate gamma 1. So, and gamma 1 is equivalent to the curve of xt minus 1. Okay, that's gamma 1, which is equal to the curve of, what is xt? Xt is zt plus theta 1, zt minus 1, plus theta 2, zt minus 2, plus theta 3, zt minus 3, plus theta q, zt minus q. Okay, that's xt. So what about xt minus 1? It's going to be zt minus 1. Where there is zt, you put t minus 1. Where there is t minus 1, put t minus 2, t minus 3, t minus 3, and so on. Then plus theta 1, zt minus 2. Okay, plus theta 2, zt minus 3, plus theta 3, zt minus 4, and so on. Then theta q, zt minus q minus 1. Let me write it nicely here. Theta q, zt minus q minus 1. Then you close the brackets. I'll stay together. Okay. Now, you group this one and this one. Okay. Because they're what? They're not independent. The same applies to this one, not independent. And this one, not independent. And this one with the one right here, because they're not independent. Okay. Stay together. So now this is equal to, I'm going to skip that step because now I understand that you understand it well. So curve of theta 1, zt minus 1, and zt minus 1. So you take theta outside, you're going to have theta 1 curve of zt minus 1, zt minus 1. So the answer is what? Theta 1 sigma squared. The first one. Then plus theta 1 times theta 2, the curve of zt minus 1, zt minus 1 is theta 1, theta 2, sigma squared z. So here you're going to have theta 1, theta 2, sigma squared z. Then say plus theta 2, theta 3, the curve of zt minus 1, zt minus 3, zt minus 3 is theta 2, theta 3, sigma squared z. Okay. Theta 2, theta 3, sigma squared z plus. Okay. So again, theta 3 and theta 4. So we're going to have what? Theta 3, theta 4, sigma squared z. And the last one will be theta I plus 1, sigma squared z. For the last part, as you see here, if we have theta 3 here, the next one is theta 4. So in other words, theta 3 plus 1, which is theta 4. The same applies to this case. If you have theta 2, so the next one is going to be theta 3. So it's like theta 2 plus 1, which is theta 3. The same applies here. You have theta 1 and theta 2. It's like theta 1 plus 1, which is theta 2. So the same applies to this. In this case, is theta I plus 1 sigma squared z. Any question before we go to the next step?
Sir,
Yes.
if I say theta q, am I wrong?
Theta q. If you say
Yes,
theta
and
q.
theta q plus
So
1.
you're going to have theta q plus 1, isn't it? So but
Yes.
remember that side we were using I. Remember, from the summation here, we use I. So that is why we convert everything to here we use I. So that the last one will be q there. But anyway, if you can use q, it's going to be the same as long as it doesn't complicate or confuse you at a later stage. You can just use theta q and theta q. But remember, the last one is q there. As long as you're following the pattern here, in this case. I've used I because I've used I there. Okay. Can I go to the next step? And the next page, rather.
Yes.
Okay. So gamma 1 now will be equal to, then you find what? The common factor. Common factor here is going to be what? Sigma squared z, isn't it? So we're going to have theta. Which one is the first one? Theta 1. Okay. Going to have theta 1. Yes.
Sorry, I had a network problem. I wanted to ask something.
Okay.
Can you go back?
Go on. Yes. Yeah.
Like on a previous tune. Yeah.
The last step.
What happened? Yeah, the last. I mean, what happened to curve of ZT? Because
ZT doesn't have any other variable here. You can't combine with anything. If you combine ZT and ZT minus 1, okay, let me show you like this.
so the answer is 0.
Yes, it's going to be 0 because they are independent. So we don't care. We can't just write 0 and then occupy our space for nothing. So that is why we left it out.
Oh, I understand, sir. Thank you.
Okay. So now plus theta 2, theta 3, is it? No, theta 1, theta 2, sorry. Theta 1, theta 2, plus, I think it's theta 2, theta 3, plus theta 3, theta 4, plus, and the last one is theta I plus 1. Then you multiply it by what? Sigma squared z. Okay, so that's it. So now, even when you are here, you can just write it in the form of summation again. So it's I equal to 0 of theta I plus 1. Then q minus 1 of what? Times sigma squared z. So that means our gamma 1 is equal to summation of theta I plus 1, where I is ranging from 0 up to q minus 1. It's up to q minus 1 because the last part there is zt minus q minus 1, if you still remember. So you see now, if you can put q there is going to confuse this at the top there. So that's why we use I. You can use I or anything, but it mustn't confuse the one at the top. Okay, now let's find the gamma 2. Gamma 2 now will be equal to the curve of xt minus 2. Yes.
Why aren't we saying that theta 0 should be equal to 1?
Yeah, isn't that we have already defined it up there? So we don't have to define it in every case. We have already defined it here. So as long as you have defined it here, so it's going to apply in all other steps that are coming. So it's not necessary just to write for theta 0 equal to 1, theta 0 equal to 1, because already we have already defined it there. But even if you can just define it there and say for theta 0 equal to 1, so there is no harm on that. Still okay. But I didn't write it here because we've already defined it up there. Okay. So now, curve of that. So what is curve of xt? Is zt plus theta 1 zt minus 1, theta 2 zt minus 2, theta 3 zt minus 3, theta q zt minus q, comma. So what is xt minus 2? Is what? Zt minus 2 plus theta 1 zt minus 3 plus theta 2 zt minus 4 plus theta 3 zt minus 5 plus theta q zt minus q minus 2. Then you close the brackets. Okay. Then from there, you can group which one? This one and this one. Because what? They are not independent. So their covariance is going to be equal to what? Sigma squared z. The same applies to this one and this one. Okay? Group them together because they are not independent. So their covariance is sigma squared z. And this one. And another one which is here. Okay? Their covariance is going to be sigma squared z. And so on. Are we together? So we are just going to write that step now. The curve of, because there is a parameter here, so it's going to be theta 2, the curve of zt minus 1, zt minus 1, okay, plus theta 1, this one, and theta 3, the curve of zt minus 3, zt minus 3, and so on. Okay, let me just go to the next step.
Sir, before you pass that step, can you please explain again?
Step number 2. Okay.
Yeah, step number 2.
I'm saying here we're grouping this one. Okay. And this one. Why? because their variable are not independent. In other words, zt is equal, zt minus 1 is the same as zt minus 1. So their covariances, the covariances of that, covariance of zt minus 2 and zt minus 2, they gave us sigma squared z. So that's why we are grouping them together. You can't group this one, let me show you. You can't group this one and this one. You see? Because here is zt minus 1, here is zt minus 2, so they are independent. So their covariance is going to give us 0 anyway. So we group this one, zt minus 2 and zt minus 2 together, because we know that their covariances, they're going to give us sigma squared z. The same applies to this one, zt minus 3 and zt minus 3. Because they are not independent, their covariances are going to give us sigma squared z. And this one, with another one which is here, which we just skipped it. We know that there is another one here, which is what? Theta, I think it's theta 4. Yes, theta 4, zt minus what? 4. You see? Then group them together. So, but the rest we are leaving them because their covariances are giving us zeros. There's no need to write them down. I don't know whether you understood. So I can proceed.
Yes.
Okay. So therefore, sorry, gamma, is it gamma 2? Yes, gamma 2.
Sir.
Yes.
Sir.
Ask. I'm listening.
Sir.
Yes.
Before you proceed, I'm confused on
which one?
Where you are saying theta I plus theta I. Yes.
I plus 1.
I'm confused where you are saying theta I plus theta. Oh, theta I plus 1. I don't understand like how you
where is it coming from?
with that.
No, this one, this part here, this one, it's coming from these values. You see these values, 3 and 4.
I understand where is it coming from, but I don't understand like.
It's the pattern. It's what I'm trying to explain. That if you check theta 1 here and theta 1 here, here's theta 2 here and theta 3 here. So here's theta 3 here and theta 4 here. So if you can go like that, so if here we just write theta I, so the next one is going to be theta I plus 1. If it's theta, or maybe you don't want I, you just use what? K.
Okay.
Or J. Let's use J. If
I
here
get
is
it now.
J here is going to be J plus 1. So in our case, we just use I because even at the top there,
okay.
Here, even here, we're just using I. You can just use J, you can use S, K, whatever. But the end part of it is that we're following a pattern here, as I've already explained. Okay. Gamma 2.
Sir.
Okay.
When you were defining this Q moving average, you said theta I ranges from I is equals to 1 to up until Q.
At the beginning.
Yes, you said theta ranges from 1.
Yes. You know why did I say that?
But here you're
Just
saying
because
from 0.
Let me just go there so that I can show you. Where is it? Up there. You mean here?
Yes.
It's just because here we are defining the thetas, these thetas, this here. For the definition, we are defining the thetas here. So that means if you have got I, it's ranging from 1 I start from 1 because we have theta 1, 2, 3 up to Q. We didn't include 0 because here we don't have theta 0 here. We don't have theta 0 there.
Okay.
You know where is it coming from? Yeah. So that is why we just say we are ranging from I. We didn't start from 0 because of the definition. So now gamma 2 is equal to what? Theta. You can tell me. Just read it for me. Theta 2. Anyone?
Theta 2 plus theta 1, theta 3, plus theta 2, theta 4,
Theta 4. Okay. Up to
plus theta 3, okay, up to theta Q plus 2.
you're using Q.
Yes.
Okay. Plus 2. Then you close it because now it was the matter of finding the common factor there. Z squared Z. Okay.
The square root.
Then from that,
sir,
yes.
is it not to the power of 2?
Eh?
Theta, is it not to the power of 2?
Oh, squared. I don't know. It's not squared. There is no squared there. Why are you saying power of 2?
Sir.
Oh, it's my mistake, sir.
There is a mistake.
From
which
No,
part?
it's my mistake.
Oh, okay, it's fine. Yes.
Sir, where does theta 4 come from?
Theta 4.
Yes. That's happening here.
Theta 4 is here. Remember, here there is a theta 4 here. ZT minus 4.
Oh, my. Yeah.
How?
Now I see it. It's because I didn't write it. So I was going to lose marks. Mario
It's
Tolet.
there.
Didn't see.
No, I didn't include it because I just jumped into the final one. But anyway, it's there.
Okay, sir.
Okay, now summation I is ranging from 0, theta I plus 2, Q minus 2. Then what? Sigma squared Z. And remember, theta 0 is equivalent to 1. Okay. Then you go to gamma 3. So if you can just go like that, gamma 3, which is equal to the curve of xt minus 3, is equivalent to, in terms of the summation, I 0, theta I plus 3, Q minus 3, then sigma squared Z. So this one, it's not necessary to calculate it. You just see the pattern from gamma 1 to 2. Yes.
Sir.
Yes.
You know, it's confusing to use I. It's
So
confusing
which
to
one
use
do you want
I
to use?
because, like, you are using I on the summation, and you are using I also there when you are expanding. Like, okay, you see where you have come as a unit sum of those coefficients, the thetas.
So
There at the
okay,
top.
which one can we use there? According to
You must use Q, sir.
Q.
You must use Q, sir.
Okay, let me just go there and see.
You must
okay,
like, okay, sir. According, let me tell you how I wrote, sir. My gamma 2 there at the end is theta Q minus 2 theta Q. It's not theta I plus 2.
The one that I
because
included
like
there.
in that form, like, okay, it's confusing to use I both and also on the summation. It does not make sense.
Okay, according to you, you said you can just use Q instead of I because it's confusing. Like Q plus 2. Okay. Is what you are saying?
No, sir, no. On the summation, it's not going to be Q. On the summation, it's going to be I. But there at the top, it's not the I.
Oh, you mean here is Q, not I, but here I stands here.
Yes.
What you're
Isn't
saying?
it that
Okay.
isn't it that we are dealing with the moving average of order Q?
Yes, that's true. So that means here when you substitute I by 1, 2, so it's going to be Q something. Oh yeah, I get you. Yeah, it's confusing. Okay, here instead of I put Q because the last one is Q there according to this one.
And it's not it's not IQ. It's not theta Q plus 2. It's theta Q minus 2 theta Q.
Theta Q minus. Okay. Yeah, what you're saying is theta Q minus 2. Yeah.
Yes, it's like that, sir. If you can go through the arithmetics intuitively, so you arrive in such an idea.
I'm confused.
Okay. Let's stop there anyway. As long as it's not confusing you. So I'll look at it whether indeed what you're saying is confusing, then we take it from there. But anyway, it doesn't change the answers, the one that we are talking about there. So it's just the matter of just putting those alphabet I or Q, whatever you wanted to use. So, but anyway, can you follow the pattern from gamma 2 up to gamma 3?
You can start.
Yes, I'm listening. So anyone there? So the only argument here is about this one. So you can just choose anyone, or maybe Q because it's referring to Q there. But anyway, the pattern is still the same, stands as the same. So don't get confused on that regard. So then you can just go and work it out later. So but at the end of the day, the pattern still remains. Gamma 2 and gamma 3. So they are going to be like this. Then remember, we're finding autocovariances. So you have to go to gamma K. Okay. So you have to go to gamma K. So gamma K, if you go like that, which is equivalent to the curve of xt minus k, will be equal to summation of, if you're still using i's, it's going to be theta I plus k, q minus 1, sigma squared z, and k is ranging from 0, 1, 2, up to q this time around. Then, if what we're saying is that if you can substitute your k by 0 here, let me show you like this. If you substitute k by 0, you are going to have theta I squared, isn't it? I ranging from 0 to q minus 1 theta I squared, which is the same as gamma 0 up there. Okay. If you substitute by 1, you're going to have theta I plus 1, which is the same as gamma 1. By 2, theta I plus 2, which is the same as gamma 2, and so on. So that means it's covered. So then if you want to use the minus 1, so
I is from 0 to q minus k, say. I is from 0 to q minus k.
Yeah, isn't it after you have changed everything? I don't want to confuse the others. Yes, I understand what you're saying. So, but in this regard, if you are just following what we're
At the top
using,
of the summation.
at the top of the summation is what? Oh, q minus k. Yes, you're right. Yeah, yes, q minus k. So, yeah, therefore, you're right. Thank you. So now, if you want to deal with the negative sign, as you remember, the properties of autocovariance, gamma k can also be equal to gamma of minus k. Remember, provided k is less than 0. Okay. Or 0 if k is greater than q. So those are the conditions. So by so doing, now we have reached the autocovariance
Sir,
functions. Yes.
can you repeat those conditions again?
Eh?
Can you repeat those conditions again?
I'm saying gamma k can be equal to gamma of minus k. Can be equal to this one. Okay? If you want your k starting from minus 1, minus 2, and so on. Okay, this is the what I'm referring to. Gamma k can be equal to this one if you want to deal with the negative side. And then again, gamma k is going to be equal to 0, provided if you want to deal with the values that are greater than q. Okay, so those are the conditions that I'm talking about. And then this is the autocovariance function. And remember, you have to calculate the autocorrelation functions again. After getting the autocovariances, it's simple to find the autocorrelation functions. So can we go to that one? Okay. So in this case, rho k is the autocorrelation function. It's ACF for what? For xt, which is defined by rho k, which is equal to the correlation of xt minus k, which is equal to what? Gamma k over gamma 0, isn't it? Now, if k is equal to 1 or 0, normally you know that rho 0 equal to 1. If k equal to 1, rho 1 equal to gamma 1 over gamma 0. So what is gamma 1? If you still recall, is the summation I starting from 0 of theta I plus 1 q minus 1. Okay. Divided by the summation of I starting from 0 theta I squared to q, provided theta 0 is equal to 1. So this is rho 1 or autocorrelation functions at leg 1. It's written as the summation of theta I plus 1 starting from 0 up to q minus 1 divided by summation of theta I squared starting from 0 to q. So that is rho 1. Then you continue and find rho 2. Okay. Rho 2 is equal to gamma 2 over gamma 0, yes. Rho 2 is equal to gamma 2 over gamma 0. Can I go to the next page?
Yes.
Rho
Yes,
2 is equal to gamma 2 over gamma 0 by definition. Okay, and gamma 2 is the same as the summation of theta I plus 1. Okay, q minus 2 divided by the summation of theta I squared q. So that is gamma 2. That is rho 2, sorry. Rho 3 will be equal to gamma 3 over gamma 0.
Sir,
Yes.
isn't the summation of gamma 2 supposed to be I plus 2?
Yes. Sorry. Yeah, you're right. Thank you. I plus 2. Sorry for that. Yeah, yes, I plus 2. Thank you for that. So rho 3 is the summation theta I plus 3 q minus 3 divided by what? The summation I 0 theta I squared up to q. Then from there you generalize it. Find rho k. Generalize and find rho k. Can I go to the next one?
Yes, sir.
Okay. So then we generalize it as rho k equal to, you can say, summation of I0 I plus k q minus k divided by summation of theta I, this is theta I squared, sorry. The I squared q, where k is ranging from 0, 1, 2, up to q. And then rho k can also be equal to rho of minus k, provided k is less than 0, isn't it? And then rho k can also be equal to 0, provided k is greater than q. So now this is the autocorrelation function at leg k. Autocorrelation functions of at leg 0, leg 1, leg 2, and so on. Any question before we go to partial autocorrelation functions? Any question before we go to partial autocorrelation functions? So now we are done with the moving average processes. So we're going to the partial autocorrelation functions. Thereafter, we are going to deal with the autoregressive processes. None. Okay. Let me just go to the next page. Can I go to the next page, please?
yes, sir.
Okay, thanks. Partial autocorrelation functions. Partial autocorrelation function. In short, is written as PACF. Stand for partial autocorrelation functions. and then is denoted by phi kk, okay, which is defined by, is denoted by phi kk, which is defined by the core of xt.
Sir,
Yes.
can you hear me?
Yes, okay.
Oh, someone was like, can you please repeat the ACF? They wrote it on the charts.
ACF.
I'm pretty sure you couldn't see it. Yeah.
You mean this batch? You mean this one?
I'm not sure. They wrote it on the
No,
charts.
go
It's
back.
like you can't see the charts when you're in this section.
Go back
Yeah,
again.
yeah.
Starting from here, I think.
So you want me to repeat?
Yeah, he wants you to repeat. Yes, he says yes.
Explaining.
Yes.
Okay. Here we're talking about the autocorrelation functions for moving average of order Q. Okay. So now the autocorrelation functions at leg K, which is called rho K, is defined as the core of xt minus k, which is equal to gamma k over gamma 0. That is the general one. Okay. However, if k equal to 0, so rho 0 is equal to gamma 0 over gamma 0, which is equal to what? 1. And you know that from the properties of autocorrelation functions, rho 0 is always equal to 1. That is why I said there's no need to calculate the autocorrelation functions at leg 0, because you know that is always equal to 1. So you can just write it rho 0 equal to 1 without calculating it. But when you come to autocorrelation functions at leg 1, which is rho 1, this one, is defined as gamma 1 over gamma 0. The question is, what is gamma 1? Gamma 1 is the autocovariance at leg 1, for which we have already calculated it. And it's equal to what? Summation of theta I plus 1, where I is ranging from 0 up to q minus 1. Then you divide it by what? Gamma 0. Gamma 0, we've already calculated it, and it's equal to the summation of theta I squared, where I is ranging from 0 up to q. So that is why at the end of the day, autocorrelation functions at leg 1 is equal to the summation of this divided by the summation of this. Okay. You got it. Okay. Then we go to the next page. We want to find the autocorrelation functions at leg 2, which is rho 2, and it's defined by gamma 2 over gamma 0. And gamma 2, as we've already calculated, is the summation of theta I plus 2, where I is ranging from 0 up to q minus 1. That is gamma 2. Then you divide it by gamma 0. Gamma 0, we've already calculated it, and it's summation of theta I squared, where I is ranging from 0 up to q. Then you divide it by that one to get what? Autocorrelation functions of leg 2. The same applies to autocorrelation functions of leg 3, which is rho 3, is gamma 3 over gamma 0, which is equal to the summation of theta I plus 3 divided by summation of theta I squared. Then later, we have to generalize everything. So when you generalize it, it's the summation of theta I plus k. Okay, which, by the way, this one is like gamma k, and this one is like what? Gamma 0. Okay, so divided by summation of theta I squared, where k is ranging from 0 up to q. But according to the properties of autocorrelation function, if you still recall, I said rho k is always equal to rho of minus k. That means if you want to deal with the negative side, so you are going to deal with the values from -1, -2, -3, and so on. So that is why we say rho k is equal to rho of minus k, where k is less than 0. And rho k equal to 0, provided k is greater than q. All the values that are greater than 0, their autocorrelation functions are going to be zeros. I don't know whether you understood me. It's clear. So now we are going to the partial
Yeah.
autocorrelation function. Then I said partial autocorrelation function is written as PACF, but denoted as phi KK, which is equal to the core. That core stands for the correlation of XT and XT plus K. Given that you have XT plus 1 up to XT plus K minus 1. This is the definition of the partial autocorrelation function. Now, phi KK, or phi 11 this time around, sorry. Phi 11, it reads as the partial autocorrelation functions at leg 1. Are we together? Phi 11 is the partial autocorrelation functions at leg 1, which is always equal to rho 1. So the question is, if they say calculate the partial autocorrelation functions at leg 1, which is phi 11, you must know that it's always equal to rho 1. Are we together? And again, if you want to deal with the simple partial autocorrelation functions, so the simple partial autocorrelation functions is denoted by phi KK estimate. That is the simple partial autocorrelation functions. It's defined by this one. So, however, if you want to calculate the simple partial autocorrelation functions at leg 1, so that means this one, phi 11, now becomes phi 11 hat, which is the same as rho 1 hat. So this is the simple partial autocorrelation function. Simple partial autocorrelation function at leg 1. See that? This is the simple partial autocorrelation. Immediately when you put estimate there, we are dealing with the samples. You know that. I know you know that. So that 1511 rho 1, it was the population. We're dealing with the population. But immediately when you put the head there, that means now we are dealing with the sample. That is why we call it a simple partial autocorrelation function. Are we together? Okay. I think it's clear. Now, if you just want to calculate the standard error of a simple partial autocorrelation functions, standard error of a simple partial autocorrelation functions, it's written as, let me use this one, standard error of a simple partial autocorrelation function, abbreviated as S phi hat KK, which is equivalent to 1 over the square root of n. If the question says calculate the standard error of a simple partial autocorrelation functions at leg k, this one is at leg k is 1 over the square root of n, and the simple standard error of simple partial, the standard error of simple partial autocorrelation functions at leg 1. So in other words, you're going to have S phi 11, okay, which is equal to 1 over square root of n. Still the same thing. Are we together? So now let's go to the partial autocorrelation functions at leg 2. In other words, it's phi 2, 2.
Sir,
Yes.
what did you say you that last thing you wrote?
This one. I say is the standard error of a simple partial autocorrelation functions at leg 1. is the same, has the same formula as this one. The standard error of simple partial autocorrelation functions at leg K. The last part is a standard error of a simple partial autocorrelation functions at leg 1, which is equal to 1 over square root of n. Now, what about phi 22? Phi 22 is the partial autocorrelation functions at leg 2. Okay, let me just go to the next page. Phi 22 is a partial autocorrelation functions at leg 2. It's equal to what? It's equal to the determinant of 2 by 2 matrix divided by the determinant of 2 by 2 matrices. It's equal to the determinant of row 0, row 1, row 1, row 2, divided by the determinant of row 0, row 1, row 1, row 0. You get that? The partial autocorrelation function at leg 2 is equal to the determinant of 2 by 2 matrices, which is that one, divided by the determinant of 2 by 2 matrices, where row 0 represents the autocorrelation functions at leg 0, row 1, the autocorrelation functions at leg 1, row 2, the autocorrelation functions at leg 2. And this can also be written as what? You know how to find the determinant, especially for those who are doing mathematics. The determinant of 2 by 2, this one is going to be equal to what? 0, row 2 minus row 1 squared, divided by row 0, row 1 squared. Are we together? Are you familiar
Yes.
with this? Okay.
Yes.
Now, this one, you know that from the properties of autocorrelation functions, okay? From the properties of autocorrelation function, row 0 is always equivalent to 1. So you can substitute it where, yes.
On the denominator, isn't it row? Isn't it working? Row 0 squared minus. I say row 0
Yes.
I say row 0 squared on the denominator.
You're right.
Row 0 is 1, so it'll be the same as row 0, I think.
It's right. It's row 0 squared anyway. But it's going to be 1. It's going to be row 0 is 1. So but anyway, to be correct, I think this is the correct way of writing it. Then, so row 0 is equal to 1. So the numerator now is going to be equal to what? Row 2 minus row 1 squared, isn't it? Divided by 1 minus row 1 squared. So if you want to calculate the partial autocorrelation function at leg 2, so that means you have to calculate phi 22, which is equal to row 2 minus row 1 squared divided by 1 minus row 2, row 1, sorry. Or if you just want to work on the determinant, you can just substitute the value of row 0 there on the matrices there. You can substitute it here, you can substitute it there if you know how to. But anyway, this is the formula at the end of the day that can assist you to calculate the partial autocorrelation function at leg 2. Are we together? Can we go to 533? Partial autocorrelation functions at leg 3. Can I go to the next page, please?
Yes, sir.
Okay, thanks. Now, 533. It reads as the partial autocorrelation functions at leg 3 is defined by what? By 3 by 3 determinant of 3 by 3 matrices. So you are going to have row 0, row 1, row 1, row 1, row 0, row 2, row 2, row 1, row 3. Okay, then you divide by the 3 by 3 again. Row 0, row 1, row 2, row 1, row 0, row 1, row 2, row 1, row 0. So this is the determinant of 3 by 3. You get it? And again, row 0, you can substitute it by what? By 1.
Sir,
Yes.
on the first row on the numerator, do we have row 0, row 1, row 1?
Yes.
It's how it should be.
Yes. Do you have your lecture notes? Just go there and just compare from what I wrote there. But it's supposed to be row 0, row 1, row 1. And the numerator there on the second matrix is row 0, row 1, row 2. And remember the row 0 there in the second one, the denominator. Row 0 is diagonal. You see that one? Row 0s are this one. Diagonal. Yeah. So now, how do you calculate this? Let me just remind you, especially for those one not doing mathematics, if they're there. Can I go to the next page?
Not yet, sir.
Not yet. I just want to remind you because I know some of you have already forgotten how to calculate the matrices of 3 by 3.
Yes, it can pass.
Yeah, done.
If
Okay,
the
let me just go to the next one. Let's say, for argument's sake, you have got a matrix A given by A, B, C, D, E, F, G, H, K. So this is a 3 by 3 matrices. Okay. Now you just want to find what? The determinant of A. Okay. What you do? Take A, find the determinant of E, F, H, K. And set minus the determinant of D, F, G, K. And plus C, determinant of D, E, G, H. Are you still remember this?
Yes, sir.
Okay. Then when you are here, you just find what? Determinant of 2 by 2. So we're going to have A, EK minus FH minus B, DK minus FG plus C, DH minus EG. So this is how you calculate the what? The determinant of 3 by 3. So I just want you to find the determinant of 3 by 3 from the partial autocorrelation function at leg 3 and see whether you can get a formula that can assist you to calculate the partial autocorrelation functions at leg 3 in future. In other words, what I'm saying is this. Here, you find the formula here. Find the determinant of 3 by 3, write it there. Then you divide by this and this, write it there. Using this approach that I showed you recently. Using this one. So it will help you, or maybe, let me just take it as an exercise. Find this one, exercise, find these values. Exercise. Yes, find here, find this. Why is it equal to? It will assist you. Okay, now let's just quickly go to the example and try to apply apply this theory here. Let me just You're done. You're still writing this. So let's find the example. Let's say the moving average of order.
Sir,
Now yeah.
sir, sir, it's time up, sir.
It's time up. Okay, let me just give you the exercise then for you to do it. I don't have any problem with the time, but anyway, let me just give you this exercise for you to do it. Or maybe from the exercise that I gave you last time, you still recall? I want you to go and find this. Yeah, the exercise that I gave you.
Sir, your handwriting. Can you please?
Do what? Modify. You want me to modify my handwriting? Is it invisible? Somebody said it's bad. Is it true?
Yeah. Okay, sir. Can I ask something?
Yes.
Are we still since we have the partial autocorrelative function of 332211, we're still going to have the sample
Partial.
the stand the
I
sample
say
partial
still,
autocorrelation.
it's still the same thing. Because here, you
And
see this
again
one.
the
Yeah.
the standard error of the
Yes.
sample, we're
Yeah.
still going
Yeah.
to
Yeah.
find it.
Yeah. But anyway, you're still going to use the same formula. So that is why it's not necessary to just introduce it here again. Because the standard error, let me say the standard error of 533 simple. Okay. Still going to give you 1 over square root of n. So that's why I'm saying it's not necessary. But still you're going to get it like this one.
Okay.
So let me just give you the exercise before you go. Remember, I gave you an exercise of xt equal to zt plus 5 over 2 zt minus 1 minus 3 over 2 zt minus 2. You still remember this one? And I said just go and calculate the ACF for xt and and the ACVS. Actually, I was supposed to start with the ACVS for xt. Okay, still remember that one? And I said you have to plot the graph and so on. So this time around, I want you to go and find phi 11, phi 22, and phi 33. You know what you're calculating? You're calculating the partial autocorrelation function at leg 1, leg 2, and leg 3 using the same exercise. Okay. Okay, it's fine. Eh? Now we can stop here, unless if you have any question.
No, we don't, sir.
Okay, thank you very much.